Okay, so today we will solve few more problems, get acquainted with the multiplication, addition of complex numbers. So have we factorized completely a cube plus b cube? Have we solved this problem earlier? No, na? Okay. Factorize completely a cube minus b cube, a cube plus b cube. Should be easy. Okay, let us use factor theorem here. And now we have got two new animals with us. Let us call this as polynomial in A. So if we substitute P of omega B in place of A, if we substitute P of omega B, then we get omega B bracket cube minus B square, B cube is equal to omega cube B cube minus B cube is equal to B cube minus B cube is equal to 0, right? That makes it P of omega B is equal to 0, means A minus omega B is a factor of P of A, implies, okay, not implies. So we have got one more factor. We already knew one factor, A minus B. Now we have got one more factor, and we need to have one more factor because it's a degree 3 equation. We need to have 3 linear factors. So try P of omega square B. That will also be omega square B bracket cube minus B cube is equal to 0. Therefore, A minus omega square B is a factor of P of A. Therefore, A cube minus B cube is equal to A minus B, A minus omega B, A minus omega square, right? So what is the learning value in this problem? That you can use the way you were using 1, 2, 3, minus 1, minus 2, minus 3, or maybe after learning possible rational root theorem, you were trying for some rational numbers also, so that the polynomial becomes 0 and you could pull out some factors out of it. Similarly, now we can use omega square, I opposite of I, etc. to pull out complex factors of the polynomial. That is good thing about this. Okay. So what obviously are going to be factors of this? A plus B is first factor. A plus omega B is going to be second. A plus omega square B is going to be third by symmetry. What best you can do is, if you multiply all 3 of them, you will find that product is a cube plus b cube, right? But then how do you get this? You substitute a is equal to opposite of omega b. Okay, let me complete. P of a is equal to a cube plus b cube. Therefore, P of opposite of omega b is equal to omega b raised to 3 plus b cube, which is equal to minus 1 raised to 3 into omega raised to 3 into b raised to 3 plus b cube, which is equal to minus b cube plus b cube, which is equal to 0, and hence a minus omega b is a factor of p of a. Similarly, a minus omega square b is a factor, and hence you get this factorization. Have you all understood? Very good. Next problem. Any doubt? Next problem, question number 3. Factorize a cube plus b cube plus c cube minus 3abc completely. Okay. Once you are done, you can show me. Okay. Let us do it now. There are a couple of ways of doing it. Let me show you first the elegant method of doing it. Method 1. Now, we already know that there is a factor of this. What is that factor? A plus b plus c. We know that it is a factor. And then a square plus b square plus c square minus ab minus bc minus ca. We know in real numbers we have already factorized this, and we know this is the factor. Now, what is so good about this factor is that it is cube root of first, cube root of second, and cube root of third. They are getting added here. That is your first factor. And therefore, a cube plus b cube plus c cube minus 3abc. If we write it like a cube plus omega cube b cube, or maybe we can write it as omega b raised to cube raised to 3 plus omega square c raised to 3 minus 3 times a omega b omega square c. I can use this equality over here because they are one and the same. A cube is a cube, omega cube is 1, b cube is b cube, omega raised to 6 is 1, c cube is c cube, and omega into omega square is 1, therefore this is minus 3abc. Okay, so if a plus b plus c is a factor of this expression, which we know, then a plus b omega plus c omega square is a factor of this expression, and there will be some another factor. Array, hey bhari, this is yet another factor. We got one more linear factor with omega. This is one linear factor without complex number. This is real factor. And now if you express the same quantity as a cube plus omega square b raised to 3 plus omega c raised to 3 minus 3a omega square b omega c, then it is one and the same. Therefore, we know that the first factor is a plus omega square b plus omega c, another linear factor multiplied by something which we are not bothered about, and hence the moment we get three linear factors, the job is just to check whether the leading coefficient is same, or are they producing the same identity, or maybe plus minus. If there is any mismatch, you need to adjust that. That is the general procedure. But in this case, you will find that it is a plus b plus c, a plus b omega plus c omega square into a plus b omega square plus c omega. This is a complete factorization of a cube plus b cube plus c cube minus 3abc. Questions? Do you have any question?
पुन्हा एकदा सांगाल का? पुन्हा एकदा जरा ब्रीफली सांगाल का?
पुन्हा एकदा सांगतो. We know that from our earlier algebra knowledge, real number knowledge, that a cube plus b cube plus c cube minus 3abc has a plus b plus c as a factor, right? And the second factor looks like this. If we express the same identity by using omega, a cube plus omega b raised to 3 plus omega c raised to 3, omega square c raised to 3 minus 3 times cube root of this into cube root of this into cube root of this, then we get same identity. And therefore, by the same logic that we use for a plus b plus c, we write a plus b omega plus c omega square. That is second linear factor that we have. Similarly, if you just flip the coefficients omega square with b and omega with c, you will end up getting the third factor. And we for three linear factors, and we got it without doing it, without actually multiplying. Okay? Any questions?
Sir?
Yes.
म्हणजे ही एक्सप्रेशन 3 वेज मध्ये फॅक्टराइज करता येईल ना?
3 ways म्हणजे
एका ह्याच्यात a प्लस बी ओमेगा प्लस सी ओमेगा स्क्वेअर आणि दुसऱ्या ह्याच्यात b प्लस a ओमेगा प्लस c ओमेगा स्क्वेअर.
Yes, so this is a very good question. That means Siddharth is trying to say that there will be total 9 factors, or at least not 9 if we keep this fellow same. 9. We are changing this, or we are keeping this same? We are keeping this same.
Keeping it same.
Yes, it has to be kept same. So instead of these two, we may have another two where b is not having any omega omega square, and maybe we have two more where c is not having any omega omega square. So are there really 1 plus 6 factors? Are there really 1 plus 6
No.
factors, or there are 3 factors only?
They will be same.
That is very good question that he has asked. Otherwise, I would have asked you that question. So what he is trying to say is, if this is a factor, why not this? A omega plus b plus c omega square, and along with that a omega square plus b plus c omega. Why not these two factors? There.
So because if we multiply it by omega, then it becomes something else.
A omega plus b omega square plus c, and a omega square plus b omega plus c. I mean, why not these two amongst any of them? But then it is going to become a 6 and 7 degree polynomial. So as far as degree of polynomial is concerned, we are failing, and therefore there must be something which is hidden in this particular.
Multiply one bracket by
Sir,
omega.
if you
They
multiply
aren't
by omega or
simultaneous.
divide by omega, then you get this.
Okay, let us write it like this. Let us first write the factor as it is, a plus b plus c. Instead of 1 times a, let us write omega cube times a plus b omega plus c omega square. And third factor omega cube times a plus b omega square plus c omega. Okay, what are we doing? We are multiplying the second factor by omega cube, and now we can take out omega common from something like that can be done. So if we take omega common from this people, we will get this. Yes or no? If we take omega common from these three, we will get this factor or no?
Yes.
तर त्याच्या राईटचा
Right.
Okay. By taking out omega common, we get this factor, omega square a plus b plus c, right? And now if we take omega cube out from this factor, omega square out from this factor.
No, sir. Omega only. You can't take.
Sir, omega square only.
Omega square, we will take it out from this. Then what will happen? Omega square inside bracket
A omega
plus b plus
c omega square.
omegas. We are falling short of omegas here, therefore we
So
multiply.
1 upon omega, so it is omega square.
We make it 4. Multiply only this identity by omega cube. So we make it omega raised to 4. So we can easily take out omega square out, and it becomes c times omega square. So omega common from this and omega square common from this makes it omega into omega square, which is 1, and we end up getting these two. So practically they are the same. This factor is this factor is this. Take out omega from this, omega square from this, you get these two factors. And that omega and omega square are not disturbing the factorization, they multiply each other to become 1. And now I think if you take omega square common from this, then you get this factor, and omega common from this, then you get this factor. So they are not 6 factors, they are only 2. समझ लो सिद्धार्थ, this is 1 and these are the 2 factors, and these are same. These 4 are, they are different looking, but they are same. They are different looking factors. Now if we have say x square minus 7x plus 10 to be factorized, we factorize it as x minus 5 into x minus 2. Okay, but we can always write this as 2x minus 10 into x by 2 minus 1. They are not different factors, it is one and the same. Arey, karte ka? These are not two different factors. These are not different factors, they are one and the same. If we really multiply these two, we get this. And if we really multiply these two, we get this. Only thing is that you have to take out 2 common from here to get this factor, and half common from here. Borobarly lena re? I think so. Yes.
Yes, sir.
To get this factor. I think I have explained it. Let us move. This was method number 1. I have said this is method number 1. So I am supposed to give you method number 2, which is brute force, मेहनत. मेहनत घ्यायची तयारी असेल तर दुसरी मेथड समजणार. Let us do it. कुठे करू असा मला प्रश्न पडला आहे. कुठे करू समोर नको खालीच करतो. Okay, so it is like this. A cube plus b cube plus c cube minus 3abc. And this method 2, which I am saying, will always work. Brute force. Factorize means start factorizing. We know first factor, a plus b plus c. We know second factor, a square plus b square plus c square minus ab minus bc minus c. Okay, so we are interested in linear factors. We got one, and now we have one factor which is quadratic. We don't like quadratic factors now, having learned complex numbers. Therefore, we have to factorize this also. So let us consider this as a square minus b plus c times a, that is ab, minus ac plus b square plus c square minus bc. Right? It is one and the same. Only thing is that I have written it looking like a quadratic equation in A. So therefore, factors of quadratic equation we know. A is equal to minus b plus c minus b plus or minus under root b plus c bracket square, b square minus 4, a is 1, c is b square, c square minus bc upon 2a. Sorry, a is 1. Right? So now we have to really keep working on this. So b plus c plus or minus under root. Let us simplify what happens inside. B square plus c square plus 2bc minus 4b square minus 4c square plus 4bc upon 2. Right? So this is equal to b plus c by 2 plus or minus half. What is this? This is a radical. We take out minus 1 common. Then what are we left with? 3b square plus, we can take out minus 3 common, it seems. 6bc. Let us take out minus 3 common. And what we are left with is b square plus, minus 2bc plus c square. If you stretch yourself little bit, you will be comfortable with this. Therefore, what is that? B plus c by 2 plus minus, this is root 3 by 2 times I. And what is there inside remaining? It is a perfect square. So we can take square root and say that it is b minus c. Okay. So now if we collect coefficient of b here, coefficient of b, then it is half plus or minus root 3 by 2 I. That is the coefficient of b. And what is the coefficient of c? Plus half plus or minus, right? Minus or plus, because it is minus c, and half minus or plus root 3 by 2 times I c. Okay. Okay. So this is what is A. Therefore, factors, if we want to write factors, then second factor will be A minus this quantity. Which quantity? I mean, let us choose the upper one now. 2b square plus c square plus 4ac square minus 4b square plus c square. What is this? This is a square root 3 by 2 times I. And what is there inside remaining? It is a perfect square. So we can take square root and say that it is b minus c. Okay. So now if we collect a minus. So let me write down a plus so that I take minus inside and makes my life little easy, which is minus half minus root 3 by 2 I times b plus minus half plus root 3 by 2 times I c. This is one factor, and a plus minus half plus root 3 by 2 I times b plus minus half minus root 3 by 2 I times c. This is second factor. But this factor we know what it is. A plus, this is omega square. B plus, this is omega. And this is A plus omega B plus omega square C. And hence we get the same three factors, but this is long, that was elegant. Have you understood? You want me to keep it on the board for some time so that you write it? Method 2. ठीक है, सांगा मला झालं लिहून की? Method 1 is elegant representation of answer, but actual answer for the first time you have to calculate using method number 2 only. Okay, and after calculating the answer from method number 2, if you know this answer and it is looking very good, that means there will be a couple of more methods to find out this answer because the answer is good. Okay, so out of that we have got this as a first elegant method, where you write down your given expression, which is a cube plus b cube plus c cube minus 3 omega 3 abc, in such a way that you exploit the property of omega. Omega cube is equal to 1. You are exploiting that property, and therefore you are making it look little different and get another factor. Make it look little more different and get another factor. That is what is the technique. It is a very good technique, but if you are asking how one will realize that they should consider this polynomial as this, that is difficult, but then having known the solutions, it is easy. Okay, so let me try. Now I have not done this anytime before in the class, but I can give you one more method where I will use factor theorem. So a cube, let me consider this as polynomial in A, which is a cube plus b cube plus c cube minus 3abc. And I would like to check p of minus omega b minus omega square c. Okay, so I should replace a by minus omega b minus omega square c cube plus b cube plus c cube minus 3 minus omega b minus omega square c, that is my a, into b into c. Now we have to evaluate this, and hopefully this will be 0. So let us find out. This is minus b cube omega cube b cube. Okay, then the second factor is, or maybe what we will do is we will take out minus sign common out, or maybe okay, minus 1, that is minus 1 cube. Then we can consider both the quantities inside are positive. So omega b cube plus 3 times omega square b square into omega square c, that is second term of cubic expansion, plus 3 times omega b omega fourth c square, that is third term of this cubic expansion, plus omega raised to 6 c cube. I am done with this expansion now, plus b cube plus c cube minus inside minus gets plus omega into omega, no, okay. So 3 omega b square c plus 3 omega square bc square. Okay, so now let me distribute this minus sign inside and reduce the powers of omega. So minus b cube.
3.
इथे 3 राहिला का?
Sir.
b cube, then minus omega b square c, then this is minus, अच्छा इथे पण 3 राहिला, minus 3 omega raised to 5 makes it omega square b c square, omega raised to 6 is 1, so minus c cube. Then outside the bracket we have plus b cube plus c cube plus 3 omega b square c plus 3 omega square b c square. Everything gets cancelled, is equal to 0. Therefore I can say a minus of minus plus omega b plus omega square c is a factor of p of a. If at all we want to use factor theorem, we can do it like this. But then again the question, how do we know that we are supposed to consider this value? And it is because we have brute force method with us and we know what are the factors. That is the only way we can explain why should you consider, because we have these factors here by method number 2. Okay? Okay. Next problem. Okay, इथे width संपलेली दिसते त्याची. अरे अच्छा, कुठे गेलं? Okay, now if n is an odd natural number, next problem. Which is not divisible by 3, then prove that x plus y raised to 3 raised to n minus x raised to n minus y raised to n is divisible by xy, x plus y and x square plus xy plus y square. If n is an odd number, natural number, which is not divisible by 3, then prove that this identity x plus y minus x raised to n, x plus y raised to n minus x raised to n minus y raised to n is divisible by this. Okay. Okay, I wait for some time. Okay, so I mean it is exactly the same way the way we have done the factorization. Consider p of x polynomial in x plus y raised to n minus x raised to n minus y raised to n. Keep finding out different factors. Now already you have been given this RHS, so you know what factors are. So is p of 0, if we put x is equal to 0, what do we get? Y raised to n minus y raised to n is equal to 0, implies x minus 0, which is x, a factor of p of x. Okay, so if we have considered this polynomial p of x, then we get x as a factor. If we consider is p of y, then we'll get y as a factor, because this is symmetric with respect to x and y. If we replace x by y and y by x, we get a same expression. Therefore, we can imply, I mean, we need not consider it for y. It's okay if we can keep it for x and say that hence y is a factor. Okay, now you want x plus y is a factor. Okay, so p of opposite of y is equal to, put x is equal to opposite of y plus y raised to n minus opposite of y raised to n minus y raised to n. First of all, this quantity is 0, so this is gone. Now here this is given information is going to be useful. It is an odd natural number which is not divisible by 3. Okay, so n is odd natural number. Therefore, you get minus into minus, y raised to n minus y raised to n is equal to 0, implies x plus y is a factor. Okay, so this is also done, this is done, this is done. Now, what should we consider now? Can you quickly figure out what are the two factors of this? This is
X minus y omega into x minus
plus y
y
omega.
omega square.
X
Minus y
omega.
minus y omega.
x plus y omega आणि बरोबर
No sir, x minus y omega
X
and x minus y omega square.
Oh, sir.
minus. Correct? Okay. I mean this is like x square plus x plus 1. If you come, and then we know two factors, x minus omega square, and you put y along with that. So that is what is the factorization. So we should try p of omega y, which is equal to x is equal to omega y plus y raised to n minus omega y raised to n minus y raised to n, which is equal to. Now here inside bracket what you can do is take out y common. Inside you get 1 plus omega raised to n minus omega raised to n y raised to n, correct, minus
Yes sir.
y raised to n. So here also I can do some, take out some common factor y raised to n inside bracket 1 plus omega raised to n. Is that right? Now let us see
Yes sir.
if we can deal with this. This is y inside bracket minus omega square raised to n. minus omega square raised to n. Why? Because 1 plus omega square is 1 plus omega square is 0. Therefore, 1 plus omega is minus omega square raised to n. And we will have to figure out what this is. So let us keep it like that only. Y raised to n inside bracket 1 plus omega raised to n. Now, so what is this now? N is odd, therefore minus 1 will survive. So minus omega raised to 2n y raised to n. Is that right? And if I
Yes, sir. But you can take y
common
raised to n
again,
common.
then what goes inside is minus omega raised to 2n minus omega raised to n minus 1 into y raised to n. Right? Now you will observe n is either 3n plus 1 or 3n plus 2. So if n is 3n plus 1, then what does this become? Let us take minus sign out.
Sir, we can just use mod.
Yeah, you can use mod, but I just
So 3n.
I want to keep
So,
it
so you
clear.
can say that there are different powers with mod 3.
Yes, but I am just keeping number theory away from this and doing it simply using algebra. Omega into 2 3n plus 1 minus omega raised to 3n plus 1 minus 1 to y raised to n. Okay, I will do it for 1, so automatically the second will come. So I'll take this 3 as a omega here, omega raised to 3 raised to 2n. Yes, and then omega square into 1, so into omega square minus omega raised to 3 raised to n into omega minus 1 y raised to n. That makes it minus, this is 1 raised to 2n, so gone, minus omega square minus 1 raised to n is gone, minus omega minus 1 y raised to n. Now this is 0 into y raised to n, 0. Therefore, this is a factor. What? X minus omega y is a factor. Okay. Similarly, now you can do it. Okay, we have to check for this. That is second part of the story. Still, this bracket will exactly look alike. And then you will have to do it for omega square y. That will complete our job. Are samajhta hai ka? Are you there?
Yes, sir.
Now you can finish the remaining part. I need not have to write it on the whiteboard. Okay. Instead, I can give you one problem because I have got how many minutes with me? 14 minutes.
15.
15 minutes with me. Yes. So let me get you a fresh problem, fresh international problem. Okay. Solve. I don't know whether you will be able to solve it in 14 minutes or not, but let me give you that problem. Solve in complex numbers. z raised to 2 minus 8 into 1 minus I times z plus 63 minus 16I is equal to 0. Simple quadratic equation. I am not going to solve it. I am going to write the final answers in the end.